Here we have lesson 7. What happens when you have more than one right triangle? So we're going to have 2 steps in order to solve for the length that is asked for in the example. So here we have example 1. Calculate a side length using more than one triangle. So it's asking for the length of C to D. So there's this length here, which I'll call angle X. Now if I were to look at the triangle that requires C to D to solve for, I only have one piece of information. I only have this angle here in degrees. So therefore, I need to solve for the length of the hypotenuse in order to solve for the length of C to D. So I'm first going to look at triangle B or ABD. So step 1. I identify angle B as 47 degrees. I am given the opposite and I want to solve for the hypotenuse. So I think which of sine, cosine, and tangent uses opposite and hypotenuse, and that is sine. So the ratio is sine theta is equal to opposite over hypotenuse. I'm going to substitute a piece of information that I know. So I have sine 47 is equal to the opposite value, which is 4.2 over the hypotenuse. I'm actually going to use the hypotenuse is going to be y. Now when you have a value on the bottom, I'm going to swap. So I have y is equal to 4.2 over the sine of 47. Using your calculator to solve for that value, you get 5.7 centimeters. So now that I've solved for the hypotenuse as 5.7 centimeters, I'm able to use that piece of information to solve for the length of C to D. So the second step, I recognize that I have the hypotenuse and I want to solve for the adjacent next to angle 20 or angle D, that is 26 degrees. So I'm going to use cos. So cos is equal to adjacent, which is the value we want to solve, and hypotenuse, the value we just solved. So cos 26 is equal to, the adjacent is x over 5.7. I want to isolate the variable, so I'm going to multiply by 5.7 on one side and multiply by 5.7 on the other. I now have cos 26 multiplied by 5.7. X is a value of 5.1 centimeters as a final answer. Turn the page to example 2, solving a problem with 2 superimposed triangles. So here we have a police airplane flying at an altitude of 800 meters. This is our height. Spots a speeding vehicle at an angle of depression of 52 degrees. So this angle here is 52 degrees. If a roadblock is set up along the same highway at an angle of depression of 23 degrees, so that would give us this value. Find the distance between the roadblock and the vehicle. So we're looking to solve for this distance here of x. In order to do that, we're going to use the 2 triangles, this triangle here and this triangle here that I just traced, to solve for that. So now we need to recognize that altogether here we have a 90-degree angle. And if we were to solve for this angle here, we would have 90 minus 23 to give us 67 degrees. And we also want to solve for this angle here, which would give us a value of 38 degrees. So I'm going to first illustrate, I'm going to solve for length Z that is made up of 800 meters and 38 degrees, and that's going to be in green. So if I want to solve for Z and I have the adjacent and I want the opposite, I'm going to be using tan. So if tan theta is equal to opposite over adjacent, I'm going to substitute the information that I know. So in this case, it is tan of 38 degrees is equal to opposite, which is z, over the adjacent, which is 800. I now want to isolate my variable, so I'm going to multiply by 800 on both sides to give me a value of z is equal to 800 multiplied by tan of 38. Z is equal to 625 meters. I'm going to save that information for later. Now in the purple, I'm going to solve for this length of y. So I'm using this larger right angle that has 67 degrees. So I'm still going to be using tan because I'm going to have opposite over adjacent. In this case, tan is 67. My opposite value I'm going to use as y, and adjacent is still 800. So I'm going to isolate the variable by multiplying by 800 on both sides. It's going to be a value of y is equal to 1,885 meters. Now, using those two pieces of information, I want to solve for the value of x, which is the difference between my y and my z value. So I'm going to take 1,885 meters minus 625 meters to give me a distance of 1,260 meters as the final answer. All right, here we have example 3, solving a problem with triangles in the same plane. So we are recognizing the angle of depression, which is formed by a horizontal, so a level of sight, and a line of sight of an object below the horizontal. So here we're working with the angle of depression, where there's a surveyor that's standing at the height of a 20-meter building. It gives us the angle of depression and angle of elevation, and it asks us to solve for the height of this building to the nearest tenth of a meter, recognizing that we need to solve for two angles or two lengths and add them together. So we know that this length here is 20. So first we need to solve for this length of x using the angle of depression and the value of 20. So I'm using opposite with adjacent. So I have at the tan ratio, substituting the values that I am given, tan 15 is equal to the opposite value, which is 20, over the adjacent, which is x. I'm going to swap my values to give me x is equal to 20 divided by the tan of 15 to give me a length of 74.6 meters for x. Now I have two pieces of information I can use for the upper triangle to solve for the length of y. So in this case, this is my angle I need to solve for the hypotenuse, and I have the adjacent, so I'm still going to use the tan ratio. So tan is equal to opposite over adjacent. I'm going to substitute the values. So in this case, tan 30 is equal to opposite, which is my value of y that I'm going to solve, over 74.6 that I just solved in the previous question. I'm going to multiply my terms to give me a value of y is equal to 43.1 meters as y. And now to solve for the overall height of the building, I'm going to take 43.1 meters, which was my value of y, plus the 20 meters that I knew was this value here based off the height of the other building, to give us a total of 63.1 meters is the height of the building. Here's our last example, solving a problem with triangles in different planes. So here I am looking from the top of a 90-foot observation tower. So it gives me the tower has a height of 90 feet. A fire ranger observes one fire due west. So we have one fire that is west and an angle of depression of 5 degrees. Notice how the angle of depression isn't the actual degrees inside the right angle. And another one that has an angle of depression of 2 degrees. How far apart are the fires to the nearest foot. Now it's actually wanting us to solve the length from the fires, and we need to recognize that this here creates a 90-degree angle. So in order to solve for our length here, I need to find the distance from the tower to one fire, the distance from the tower to the other fire, and then I can use Pythagorean theorem to solve for my third length. So I've redrawn it with the angles labeled. So I took 90 degrees minus 5 degrees to give me 85 degrees, and 90 minus 2 degrees to give me 88 degrees. I know the pole or the tower is 90 feet, so I have two pieces of information that I can use to solve for my length, which in this case it is solving for the opposite. So that will be x, and the opposite in this one will be y. So I will start with solving for the one on the left, so the value of x as I labeled it. So I'm going to use tan is equal to opposite over adjacent, because this is my angle of orientation. I want the opposite and I have the adjacent, recognizing that there are two 90-degree angles there as well. So substituting the information that I have, tan 85 is equal to x over 90. Isolate the variable by multiplying by 90 on both sides. Tan 85 multiplied by 90 gives me a value of x of 1028.7 feet. And I'll use that information later. Now to solve for length y, same setup. I'm going to use the same ratio, opposite over adjacent. In this case, the angle is 88. I'm going to use value y over 90. Multiply by 90 on both sides, isolate the variable. Tan 88 multiplied by 90 gives me a value of y of 2,577.3 feet. And now I'm able to use those two pieces of information to use Pythagorean theorem. A squared plus b squared is equal to c squared. So 1028.7 squared plus 2,577.3 squared is equal to my value of c squared, to give me a total value for the distance between the fires of 2,775 feet between the fires. That is all for the 7th and final lesson.